Good morning. Today we are going to see the second part of the oral questions. First part already uploaded. Now we will go with the second part. Just we will revise first part. So we have seen stress. Then we have seen three materials: elastic, elastoplastic, plastic. In plastic, our value of stress is 0. Then we have seen conversion of units. Then we have seen different suffixes which we are going to use over there. Then different types of stresses. Then we have seen strain, unit of strain, and then relationship between the three moduli. Then we have seen lateral strain, unit of lateral strain, and then we are with Poisson's ratio. This we have seen in first part. Now today we will go with second part. So in second part, we have K. So just I will go little bit back again, which is equal to sigma V upon epsilon V. So we have rate stress directly proportional to strain, and constant of proportionality we have bulk modulus. Now important to find value of epsilon V, and epsilon V, we have derivation, we will not go with that derivation, but from that derivation we will get epsilon V. Actually epsilon V, we have delta V by V, and by deriving it, we will get this value as epsilon linear plus epsilon lateral, and in lateral we have along thickness and along width. So epsilon lateral along width. And we know we have actually epsilon lateral, that is nothing but mu into epsilon linear. Sorry, this will be my plus mu into epsilon linear. This value actually we have, if we will go to this calculations, then you will get this value. We are generally getting it as minus. Now we have to add, but if we will go with algebraic sum, then this value you will get it as minus. So this I will mention minus. Why this is minus? Because if I will apply force along a length, then my length increases. At that time, my other dimensions are going to be decreased, and therefore strain we are going to get it as minus, and this also I will get as minus mu epsilon linear. And if you will take linear common, then I will get epsilon V is equal to epsilon linear in bracket 1 minus 2 mu. You may ask why these values are minus. So you have to explain from this. So this is your epsilon V, that is volumetric strain. And volumetric stress, I already mentioned, when you have any body at a higher depth in water, then the stress acting on it in all directions, that is all three directions, that is nothing but sigma V, which is same. That is your volumetric stress. So volumetric stress. So you should be in position to answer also this volumetric stress. So this is first part of this. Then you may ask, that is question related with determinate and indeterminate. So we already know determinate problems we can solve using equilibrium equations only. And we know we have equilibrium equations 3, that is summation fx0, summation fy0, and moment 0. But in these axial forces, we require fx0 or equal fy0. Now, in case of indeterminate structures or indeterminate beams, we have to apply equilibrium equations along with compatibility equations. Compatibility equations. Now, what are compatibility equations? The equations which are compatible with the support. Compatible with supports. Now, what are that equations? I already mentioned, if you remember, if we have body which is fixed between the two supports, then we are going to say delta L equal to 0. No deformation will be there. And our value of delta L 0, which is my compatibility equation. Then we can have, if we have two materials, so this is my one material or tube I can say, and this tube is fixed. Sorry, a rod is fixed in this tube. So we have this will be tube and we have this will be rod. And then we are going to be, these two are fixed between the two plates. Then what is my compatibility equation? So my compatibility equation for this case, if I will say this is copper and this is tube is steel, then I have delta L of copper equal to delta L of steel. So we have, these are the equations which we are going to use as compatibility equation to solve the problems. So this determinate and indeterminate, we should be careful with the answers. And then last part in unit 1, we have temperature stresses. Now this is again most important. Student make mistake answering the questions of this. Now is very simple. If I will keep a body that is free and temperature increased or decreased, then no stress. Important, no stress will be developed in the body. No stress in the body. I already mentioned when, why? Because this body is free to expand or contract. Whenever you are allow any body to expand freely or contract freely, then no stress will be developed in the member or in the body. Now same, if I will prevent their deformation, means if I will consider a body and we have body in this mesh and this member we are going to keep between the support. And then if we increase or decrease the temperature, stress developed. Stress developed. Why stress developed? Because stress developed because deformation prevented. Deformation prevented. And whenever deformation prevented, stress will be developed. Now, if I increase the temperature of this body, increase temperature, then which stress will be developed? So if I will increase the temperature, your member will try to expand, try to increase their length, and in that case, stress is developed or reaction developed. that will be in this fashion. It will try to keep the body between the support, and therefore, when temperature increased, compressive force will be developed. Because we are going to prevent its elongation, and as its elongation is prevented, so automatically compressive force will be developed. If I will decrease temperature, then what will happen? So body will try to contract. So if I will draw another diagram, in this case, your body will try to contract, and body will try to contract, and therefore reactions developed are tensile in nature, and therefore tensile, not force. So compressive force we can say, but we are talking about stress. So compressive stress or compressive force, instead of this, I can write compressive reaction. And same here, tensile stress or tensile reaction. Stress or tensile reaction. You should be in position to explain why this has compression and why this has tension. So due to temperature increase, body try to elongate. We are going to keep body between the support because we have fixed support. And in that case, compressive reactions will be developed, which will develop compressive stresses. And in the same way, we can explain for tensile by drawing this diagram. So this we are going to say single member if we have compound body. Compound body. Now this is again important. So compound members. Now in this we have two bodies. We have one member we have, and then we have another member which is attached to it. So let us we have second member. And now we are going to heat the temperature. These are attached. They will act combinedly. And this I will say 1, this will be 2. So we have alpha 1 greater than alpha 2 and temperature increase. Now try to understand. When temperature increased, if we will keep these two bodies separate, if I have this will be body 1, then it will elongate like this, which I will say as delta L1. Then I have another body which is 2. And this will be lesser one. So this will be delta L2. This is first, second. But if we will see, we have final elongation will be in this fashion, which will be delta L. And this delta L, it is greater than delta L2 and less than delta L1. What it indicates? We have to reduce value of delta L1 and we have to increase value of delta L2. If question asked, you should be in position to explain like this. And therefore, we have in 1, you can see force and summation Fx0. So both should be P. And therefore, we have in this compression and in this we have tension when temperature is increased. Now we have a reverse. Otherwise, if temperature is decreased, so question may be in this fashion also, and it should be in position to explain what will happen in this case. I will draw this same. So I have this as 1 and I have this as 2. What will happen in this case? So in this case, this will reduce. So we have in this fashion, So we have this will be delta L1. Here we have decreased temperature. Decreased temperature. And then it will decrease less, which will be delta L2. But final deformation will be same, and that final deformation will be between delta L1 and delta L2. So we have final deformation. So just I will draw that final deformation. Body will come to this position, and this will be delta L. Now what will be your values? So you have delta L. This will be less than delta L1, and this will be greater than delta L2. What does it mean? So try to understand. We have delta L. This is greater than delta L2. So what does it mean? We have to take this inside. This we have to take a little bit inside, and this we have to pull outside. So this will be tensile, and this will be incompressive in nature. And therefore, we are in this case, 1 where we have alpha 1 greater have tension, and 2 which have alpha 2 lesser than alpha 1, we have compression. So try to explain these parts. So if you explain it properly, then only you will get marks for this. So these are the tentative questions which are related with your unit number 1. So now we will stop here only. Remaining part we will see in the next video. So thank you.